This standard is about applications of linear systems. We're going to read some word problems in this section and try to find some numbers that'll make those word problems true. So the first step in a word problem is to define the variables. You need to think about what it is you're trying to solve. Then you write some equations with those variables, and then you solve the equations. So here's our first application problem. The difference of two numbers is 10. Twice the first number added to the second number is 5. What are the two numbers? So I'm going to define some variables here. I'm going to say f is the first number. And I'm going to say s is the second number. So the difference of two numbers is 10. Difference means subtracting. So f minus s is 10. Is usually an equals. Twice the first number added to the second number. Twice the first number is 2f. Added to the second number is equals 5. What are the two numbers? So now I'm going to solve the equations. So to solve these, I'm going to go with combination because I see that the minus s and the plus s are going to cancel each other right out. So I'm going to add these equations together. F plus 2f is 3f. Those guys are gone. And 10 plus 5 is 15. So divide by 3, divide by 3. The first number is 5. And so I'll put f as 5 in the first equation. So 5 minus s equals 10. So to solve for s, I'm going to subtract 5 from each side. Negative s equals 5, or s equals negative 5. So the first number is 5, and the second number is negative 5. Let's just check and see if that works out. So the first number minus the second number. So 5 minus negative 5. Does that equal 10? That's plus a positive, so yes. And putting it in the second equation, 2 times the first number, so 2 times 5, plus the second number, plus negative 5. Does that equal 5? 10 plus negative 5 equals 5. Yes, that works. So that is the answer to the problem. Next problem. An exam worth 145 points contains 50 questions. Some of the questions are worth 2 points, and some are worth 5 points. How many 2-point questions are on the test? How many 5-point questions are on the test? So let's define some variables here. I'm going to say t is the number of 2-point questions. And I'm going to say f is the number of 5-point questions. So there's 50 questions total, so that must mean that the number of 2-point questions plus the number of 5-point questions equals 50. And I know the total number of points is 145 points, so 2 times the number of 2-point questions, so that's how many points come from the 2-point ones, plus 5 times the number of 5-point questions, that's the total number of points from the 5-point ones, has to equal 145. So there's my two equations. To solve them, I think I'm going to go with combination again, except I'm going to have to multiply by something. I think multiplying the top equation by negative 2 is going to be the easiest. So that top equation turns into negative 2t minus 2f equals negative 100. So those cancel out. That means 3f equals 45. Divide by 3, divide by 3. So the number of 5-point questions is 15. The number of 2-point plus 5-point adds up to 50. So that means the number of 2-point is 35, because 35 plus 15 is 50. This problem's a little bit different from the last one. Let's read through it and think about what's going on. The Student Council at Somerville High School is making t-shirts to sell for a fundraiser at a price of $12 apiece. The costs, meanwhile, are $8 per shirt, plus a setup fee of $100. Selling a certain number of shirts will allow the student council to cover their costs. How many shirts must be sold? So the question I'm trying to answer is how many shirts. So I'm going to say S is the number of shirts. So what I want to know is when the money I bring in from selling shirts is going to equal the money I spent to make the shirts. So I want to know when the money I made equals the money I spent. So how am I making money here? I'm making $12 per shirt. So the money made is 12 times the number of shirts. And I want to know when that equals the money I spent. So I spent $100 to start, and then I spent $8 per shirt. So I want to know when those two things equal each other. So I'm just going to go ahead and solve this one equation. So I'm going to subtract 8s from each side. That's going to give me 4s equals 100. Divide each side by 4. And the number of shirts is going to have to be 25. So if you sell 25 shirts, you make exactly as much as you spent. We can also think about this using a picture. So I'd like to look at the dollars I spent compared to the shirts that I made. So let's see, let's go back and look here. I was making $12 per shirt. So I can write an equation. The dollars made from shirts equals 12 times the number of shirts. And I can also write another equation for the money I spent. So there was a setup fee of $100 plus $8 per shirt. So the dollars spent is $100 setup fee plus $8 per shirt. And I want to know when those two things are going to be the same. So let's graph them. So I'm going to start off at 0. And then I need to think about how to graph these so I can work with the scales I have on this graph here. I'm going to go up by 5s. So if I've sold 5 shirts at $12 a piece, I brought in $60. So 5 is up here at 60. It's about there. 10 shirts, it's going to go up to 120. 15 is 180. 20 goes up to 240. 25 goes up to 300. So let's try to connect those. That's the graph of dollars brought in for number of shirts sold. Now let's think about the money that I had to spend to make those shirts. So I'm going to start off at $100. And after selling 5 shirts, I spent $140. So 5 goes up to about there. 10 shirts, $180. Just about there. 15 shirts, $220. About there-ish. 20 is 260. And then 25 goes up to 300 again. So that's kind of a special point right there. I'll try to connect these. So this point right here is where these two lines cross. That's the point where the money you spent making the shirts equals the money you brought in selling the shirts. We have a little more information in this graph. We can see that that dollar value is $300 when you break even. And if you look down at the bottom axis, you can see you sold 25 shirts at that point, and that's the same answer we got up here when we just did it using algebra. So the graph helps us to see a little bit better what's going on in this situation.